This is question 8 from the 2019 Ordinary Level Leaving Cert, paper 2. As you can see, it's a section B question, which means it's big and lots of writing in it and lots of things to figure out and take apart, but don't get too afraid by that. The questions aren't that difficult. Well, maybe part B is, because it's split into two parts. Part A is area and volume, very standard questions you will see over and over again. Part B is statistics, a little more tricky, a little more memorization needed. But actually you do see that type of question quite a bit the last couple of years. You can find a link to the image of this question in the description below if you need it. I of course recommend you do this question, you attempt this question before watching this video. Okay, part A of this question asks us about a solid sphere, 3 centimeters wide. Let me just put it in here. 3 centimeters wide is dropped into a cylinder and then water is poured in the cylinder. Here's my attempt at a picture. It's much better in the question. And water is poured all around this. Okay, that's not really important to part 1 though. Part 1 simply asks us to find the volume of the sphere. Find the volume of the sphere in terms of pi. They often say in terms of pi. We use a formula from our tables. I'll put that up on the screen now for a few seconds. You can see it there. It's 4 over 3 pi r cubed. So let me write that down. 4 over 3 pi r cubed. In this case, the only thing we don't know is r. That's all you need for a cylinder. For a sphere. All you need is the radius here. So we can write this down again. 4 over 3 pi and 3 cubed. Let's start cleaning this up a little bit. 4 over 3 pi, 3 cubed is 27. And we can multiply this together. Well, the 3 will go into the 27. It's the easiest way, I think. 3 will go in 9 times. So we're just left with 4 times 9. So the answer here is 36 pi. So that's what it means to leave your answer in terms of pi. This is a perfectly good way to write a number. And we'll see that later in the question even more. 36 pi's is actually a neater way to write. If you multiply this out, it would be, I'm not sure what it'd be, something like 110.73421, something like that. Really messy, really big. Whereas this is, and it's not even exact. Unless you go on forever and ever, you won't get an exact answer. Whereas this is exact and nice and short. So I quite like that. Part 2 says the sphere is removed. The internal radius of the cylinder is 5 centimeters. Okay, they finally told us what the cylinder is here. It's 5 centimeters. So they removed this sphere from it. So what does that... Oh, then they ask us how much is the height of the water moved. So let me draw this again here. I'll just draw the cylinder this time. And let's see, there's the bottom of it. And we've moved the water out. So the water has dropped this much. Now they tell us the cylinder is 5 here. They haven't told us the height of the cylinder. But that's okay, because I don't need this picture here. I don't need this cylinder, I mean. The cylinder I need is this one up at the top here. Because they're asking us about the height here. This is the question. They're asking us about that height. So let's talk about that cylinder. If they're asking us about that height, why talk about the big one? So let's draw the small one again. That's there. That wasn't too bad of a drawing. Okay, so this height, let's put in a letter for this. We can put X in if you want, or I'll just put H for height. And this is still the same radius. So we're still 5 radius here. So it's this cylinder I'd like to talk about. And we want to know what this height is. We need more information. We need to know what maybe the volume of this is. And it's just a physics question, this. It's the Archimedes principle, I think it's called. I'm not. Don't quote me on that one. But simply, if we take the ball out of the water, the height of the water will drop the same as the volume of the ball. So I actually know what the volume of this cylinder is. The volume of this cylinder is equal to 36 pi. We know what the volume is. And again, let's go to the formula book again. We know what the volume of a cylinder is. It is pi r squared times h. So let's put that in. This is the volume. But we also know another way to write it would be pi or squared, that's 5 squared, times h. We now have an equation. We don't need this part here. Let me rub that out. We now have an equation. And have a look. Is there anything we don't know in this equation? 36 we know, pi we know, 5 squared we know. Only h. So we can solve this. Let's rearrange everything until h is on its own. Okay, first let's divide both sides by pi. 36 pi divided by pi is equal, pi divided by pi is gone. Let's multiply this out. 5 squared is 25. H, pi divides pi, that goes in once. Okay, let's divide both sides by 25. We get 36 divided by 25 equals 25 divided by 25 is 1. And we're left with h. That's the answer. Let me just write that again here. H is equal 36 over 25. And that's in centimeters. That's perfectly fine as an answer. You could divide this in. Have I done this here? No, I haven't bothered to do it. In fact, and you really shouldn't though, because the question asks you to find the height. They don't say to the nearest decimal place. They don't give you the option to round it off anywhere. They want the exact number. Well, actually, I guess this would multiply in exactly. I can divide this in my head now that I think about it. If you just multiply 36 by 4, you will get 144. That'll be divided by 100, which is also equal to 1.44 centimeters. That's fine. I guess that is fine, the way to write it. I like fractions better than I like decimal places. So both answers are 100% marks. Okay, the cylinder, sort of a new part to the question. Let's see, I think we have room here. The cylinder is going to be cut out of a shape. So if you have a look back at the question, the cylinder, the curved part of this cylinder, so no top and no bottom. So that's important. Even though we need a bottom to fill it with water, that's not what we're making here. So this curved part of the cylinder, let me draw it one more time. And remember, there's no top or bottom on this one. How do we make that? So imagine if there was a line cut there and we spun it out. Think of maybe get some the toilet roll, the center of the toilet roll at home. If you cut a line there and spread it out, what you get is something the same height, and it just rolls out to here. That's what a cylinder looks like if you unfold it. And we know a lot about this. They decide to tell us what the height here is 18. So that means the height of this is 18. They don't tell us, but we need to know what the length of this is. We do know it's 5. So this is really what the question is asking us. We forget what you need to be able to do to answer this question, and what the hardest part here is just to find this length. So that's really what they're asking. And the length of this is the same as the length all the way around that circle, because it unrolls. So think if this point is here, this point is here, this point is here, this point is here, this point is here. It's the same length. So all I need to know is the length around a circle. So let's go back to the tables. I'll pop it up on the screen again. The formula for the length, the perimeter of a circle is 2 pi or in this case, because we know or is 5. Yeah, let me just rub this out. It's a good place to put it. It's 2 times pi times 5. So that's no, let me write here. 2 pi or was the formula. That's equal to 2 pi 5. 2 times 5 is 10. 10 pi. 10 pi is the length here. Now again, you can use a decimal place here if you want. Obviously, pi is 3.1415 something something something. So I guess that's fine, but I like to leave the exact answer here. Yeah, I'll leave that there. Okay, so that's the shape of this cylinder. So back to what they asked us. They gave us a piece of metal. They won't always draw it like they did, but they gave us a big piece of metal here, and they told us it's 35 and it's 20 high, and they tell us they cut this bit out. What's left over? So really what they're asking is, big piece, minus small piece equals what? Equals this piece. But let's get the areas, okay? So the area of the big piece is 20 multiplied by 35. Put it in on a calculator if you're not sure. That's 700. Let's put it in centimeters squared. And the area of the small piece minus the area of the small piece, that's 10 pi times 18. Again, put it in a calculator if you want, but 180 pi is fine by me, I think. We'll have to round it off eventually. They want our answer in decimal places. But I like to leave pi till the very end. So that equals what? Again, let me put a centimeter squared there. Put this in a calculator. 700 minus 180 pi. That's not 180, it's 180 pi. And that will give you the answer. Let me see, I have it done here somewhere. 134.5. There's more decimal places, but round it to one decimal place. 0.5 centimeters squared. Okay, so that's part A there. That's how we do all areas and volumes. If you have any questions about that, put them in the comments below. But I'm going to rub this out and move on to part B now. Okay, I've put the question back up on the screen so we can read part B together here. In September 2018, a European Commission report stated that it is considering a proposal to abolish daylight saving times. Now, this is a very popular question, things like this. It doesn't really matter what the question they're doing, what the survey they're doing. It's more about the numbers. In this case, this would mean the clocks would go forward 1 hour. Again, this is just information you don't really need at this point following October, blah, blah, blah. A transition year class carried out a survey to find local people's views on the proposals. Okay, so let's get down to the actual important bits of the question. The class surveyed a random sample of 800 people in the local area. Find the margin of error of the survey. Okay, so part 1 is asking us to find this margin of error of the survey. Give your answer as a percentage. Now they put percentage in bold, correct to 2 decimal places. That's actually going to be important at the end of the question. But first of all, let's do the start. Find the margin of error of the survey. Unfortunately, I don't particularly like statistics, and one of the reasons is you need to memorize some things. You need to just remember what the margin of error of a survey is, how to get the margin of error. It's not in your formula books. It's sort of in there if you understood more statistics. This book, your formula tables, this is Irish students I'm talking to now, and the formula tables is made for college students as well. So there's complicated statistics in there that sort of hint to this answer, but not quite. Margin of error we class as 1 over square root of n. This is something your teacher would have told you. It'd be in your textbook. Something you need to remember. Margin of error is 1 divided by square root of n. What is n? It's the sample size. In this case, it's 800. If you ask 800 people a question, the margin of error is 1 over square root of 800. And we can just put that in the calculator. You will get... oh yeah, here's the next important part. You will get this out of the calculator. 0.0353553. This is going on here. And the question asks you to give corrected 2 decimal places. So here's something wrong, a big mistake a lot of students made. They put this to 2 decimal places. They put this equals 0.04. Let me put a big X there. That is the wrong answer. They did not want this rounded to 2 decimal places. They wanted the percentage rounded to 2 decimal places. This is not the percentage. This is a decimal place. To get the percentage, to turn this into a percentage, we need to multiply by 100. This is equal to 3.53553, and that continues on forever. This is the question they wanted us to round to 2 decimal places. They wanted this one to be 3.5. 35 is closer. Well, 35 is in the middle. I like to think of it as 355 is closer to 400 than 300. So we'll put the 4 in. All right. So that is part 1, corrected 2 decimal places, and that was called the margin of error. Try to remember that. Okay, part 2. Similarly, now you're going to have to memorize things here as well. In the survey, 350 people supported supported the EU proposal. Use your answer from part B1. Use this answer. So that's a good clue. It's a lot of help there. To create a 95% confidence interval for the percentage of the population who support the proposal. So what percent support the proposal? First of all, you might just jump right in and say 350 supported out of 800. Well, then the percentage is, and this is how you should start it, the percentage of this little sample size is 73.75%. Put a little percent there. Where else have I got percentages? Let me put some of them in. That is the percent of that small sample. But we want to know for the whole country, for the whole area, for the whole world, so a bigger sample size than this. So this isn't guaranteed to be correct. Remember, we only asked 800 people. Well, there might be 50,000 people in this area. Maybe in the whole country, it's 5 million people. So this is not accurate enough. So we need a confidence interval. Now, interval should be a little clue. If you have the right answers here, or this is our guess maybe, we often do a plus or minus like this. We often do, well, this is the answer, but I'm not sure either side. So look what we had in part 1. They're giving us a little help here. Part 1 is margin of error. This margin of error, this is what we think, but we're wrong maybe by this level. And well, this is good enough for ordinary level. This is the answer to this question. What the answer would be, the probability is either, let me give myself a little more room there. The probability is less than or greater than something. So we need this interval. We need one big part, one small part. This is probably around the middle of it, but it's less than 43.75 plus something, and it's greater than 43.75 less than something. So something smaller than this number and something bigger than this number. The correct answer for this leaving cert, we're finished if we put this in here. We just need to take them away, and we put this number here. But just in case there's students out there who do honours level and maybe have dropped down to ordinary level, there is a more exact answer. And the exam is happy to take both of them. This is good enough for the ordinary level, this confidence interval. Let me finish this off here. This number will be 40.21, less than P, less than 47.29. So this is our best guess of an answer, but we know we have a margin of error of this much. But a 95% confidence of error is actually a more complicated formula. And again, this is okay to do in the ordinary level, but it's not necessary, and most students wouldn't. So this is correct, this answer. But you could also have got 43.75, 43.75. You could have also got a different number here. And a slightly better, more accurate number, but you'd have to use a formula, and that formula is 1.96. Well, I'll discuss this number in a moment. P multiplied by 1 minus P over N. This formula, luckily enough, this part of it is in your formula tables. This same number goes here as well, by the way. Let me just do that there. Save me right now again. This is in your formula book. It's just harder to remember, I guess, this bigger one. This number here needs to be memorized by honours students, or they need to do even more complicated work to figure it out. Okay, I'll talk more about that in an honours level question. But for now, I just wanted honours students to realise you could use this, even though you'll get quite a different answer. By the way, P is just this number here. Often put in like P hat or something, our best guess so far. And P is this number, not 43 now, 0.43. 0.43 would be P. If you put all this in, you would get, let's see, 47.19 and 40.31. This is also correct. They will accept this as an answer, although it's just more work than you needed to do. And you can see it's close enough. This one's just a little more accurate. It's inside this one. if I draw them again, there's our best guess. And we're saying, and this one's saying, look, we're between these two numbers because of the margin of error. We're between these two. Whereas if we got did a little more maths, this person here might say, you know what, I'm 95% sure we're between here and here. This person, they're actually, it's not in the course, but they're not 100% sure either. But it's a little more than 95%. It's just a rougher guess. This is more exact as a guess. Okay, yeah, that's part 2. Yeah, let's do part 3. I need some of the numbers from here. Any questions about this, by the way, put them in the comments below. I'll do my best to answer you. Okay, so part 3, they love this question, and I think it's a good question to ask because it's an important thing to know in life. A local newspaper has reported that 50% of people in the area support the proposal. So they haven't said more than 50 or less than 50, they've said exactly 50 support it. Use your answer in part B2 to conduct an hypothesis test. Again, we have to sort of memorize how to do this question, I'm afraid. At the 5% level of significance. To test the newspaper's claim. State your conclusion. That's important now. State your conclusion in the context of the question and give a reason for your conclusion. Okay, first thing I'd like to say here is, just like I have 2 answers here, one for honours, this question will also have one for honours. Well, no, it's actually the same answer. It's just an honours student could use this, or an ordinary student could use this. They might get different answers. That's a bit of a problem. But in this case, they'll get the same answer. Okay, so to do an hypothesis test, you need to state your null hypothesis. You need to state this. You need to state H0. You don't have to write H0 necessarily, but you would have to write null hypothesis if you didn't remember to write this. You need to write the null hypothesis, or H0, and say what it is. Maybe just put a few dots here, just null hypothesis, and then what is the null hypothesis? Let's see. That 50% of people support. 50% support. You can use a little more English, but you just need to get some of the correct words. But I'd say use more English maybe. 50% support the proposal, support the initiative, and like 50% support. So then you need the opposite to that. You need the counter, the alternate hypothesis. And we usually write that as H1. More complicated statistics, we might have more here, but we're always just going to have H0 and H1. And the opposite of this is the level of support. Let me write all this out. The level of support is not 50. Sorry, is not 50%. So all we need to do is it 50 or is it not 50? So the level of support is this. So maybe I could have rewrote the first one as the level of support is 50%. The second one is the level of support is not 50%. And that's what the test is. And to do that, we just need to find some evidence about it. And we usually use our interval here. For an honours student, the fact that it said 5% significance, that means we would have to use 95% interval. And they would have to use this exact number here, this interval here. But in ordinary level, we're going to use this interval. I don't think this is a 95% interval, even though the question said it was. That's why I've just been a little awkward there. But in an ordinary student, we're going to use this number here. But again, you could have used this number, it's fine. So do 50% support. We're 95% sure. No, we're 95%. The level of support is between 40 and 47. Like we're 95% sure about, well, I'm 95% sure about this number, but we're 95% sure. No, that is within a 5% level of significance. So I can say no, it's not. This one's not true. So how do we write that? And it is important to write something like I'm about to write. Let's see. Yeah, I'd like to state something. The evidence is 50% is not in this interval. 50% is not in the confidence interval. The confidence. Let me just write it out. Confidence. I'm not very good at spelling, so I apologise if I get anything wrong. is not in the confidence interval. Seen here, that'll be right above this in your question, hopefully. And therefore, we reject. Yeah, we reject the null hypothesis. So this is the thing we're assuming at the start. We reject the null hypothesis. I can't spell that. I'll give it a go there. We reject the null hypothesis. And therefore we accept this. So therefore, the level of support is not 50%. So I'll just accept the second one. I'll just write H1 again. The level, you'll get away with less English than this, and you'll also get away with more English. But you do need something like this. It's a question that you should just do lots of practice of. There'll be more questions in your book just like this. And it's very popular in the exam. Probably for the next year or two, I think it will be popular. They want to make sure everyone knows it, and one of the ways they want to make you know it is by doing it in past exams. Is not 50%. Okay, that's the full marks of that question. But as I said, an honours student, the difference would be they just have to use this number here. And again, in an honours question, they might ask this question, just part 3, and make you do all this, make you know to do all of this first. Alright, if you have any questions about this, and you should, this is a complicated subject. The problem with the Leaving Cert is we teach part of statistics. When you get to college, you'll learn more complicated statistics. You get post-college, post-graduate, you'll learn more complicated statistics. I'm sure I haven't. So it's an awkward one. There's often little gaps in. We're not exact in a lot of our answers. And you'll even have different things in different courses around the world. Slight differences. For example, some people would just use 2. Some countries would just say, look, 2 is close enough. We don't need 1.96 here. Anyway, any questions, put them in the comments below. I'll do my best to get back to you. Until next time, have a good day.